Let's now open another capture file. One of the easiest ways to check what's been happening in the network is to analyze the DNS protocol. Wireshark allows you to filter the data by selecting something in the Packets Details pane, then choosing Apply as a Filter or Prepare as Filter. In our case, we choose the protocol name and the packet type. Data can be filtered in many different ways. Let's see how much information we can get from DNS. We can choose the protocol we're interested in and corresponding field. In our case, it's source. When you click on it with the right mouse button and choose Prepare as Filter option, you can create more complex filters. Now we can observe the DNS communication of the chosen client. After a short time, we'll be able to tell what programs have been running on the computer and what its users been doing. The DNS is a protocol that can give us all of this information. As you can see, to connect to a device in the network, you must first get to know its address. You must first send a request to the DNS server. Let's see another example. We've captured data concerning network users. In this case, someone is connected to HTTP servers. To get a general overview of what happens in a capture file, let's start with the Statistics menu. We'll examine the HTTP statistics and the packet statistics. You can apply data filters to the statistics too. In our case, we will create the statistics based on all the packets. The capture file contains the following information. The client we've chosen sent 144 GET packets. This is 100% of the activities performed by the user. We see the responses below. Is there something in these responses that may be troubling? Not necessarily from the security perspective, but from the management perspective. Let's have a look at the HTTP server's responses. Right now, we don't know what servers they were or what happened to the data. We see 140 responses, out of which there were 80 OK responses and 57 redirection responses, where a server responded to a client that some data had been moved to another location. Interestingly, the not found message of the HTTP protocol indicates a client error. The client wanted to connect to something that doesn't exist. The server isn't responsible for the missing content. We can analyze the data using various statistics. For the same item, let's see the endpoint list for TCP. It turns out that servers redirected our requests not only to different addresses, but also to different ports, so we're not able to trace the data. We managed, however, to generate a list of IP addresses of hosts that were involved in the communication. From the number of packets generated by the host, we can guess that the selected address is the client's computer. The list contains the IP addresses of all computers we were redirected to. Let's see what other information we can get from the DNS server. Let's open a file with the data captured when the computer was starting up. An interesting experience is to monitor the computers left unattended, that is, those with no one at the keyboard. What does the computer do when no one uses the keyboard? Some of the programs installed on the computer are very chatty. Particularly interesting is what happened with the computer when it was starting up. We know that to find out who the computer was connected to, we should filter the data for the information from the DNS protocol. We can see that the computer has the McAfee antivirus installed on it. We also see that the program tried to perform an update. Next, there is a query sent to the virtumode.com server, which isn't a McAfee server. If we did some research about this server, We would learn that this is a website that virus is connected to get instructions concerning further actions. It was the site used to coordinate attacks. Normally, the detection of such a situation is not all that easy, but the capture file and the filter on the DNS server will show us all such information. If you learn that the computers you look after connect to the websites that you know nothing about, check them out, and everything will become clear. To achieve all this, we only needed to know how to use Wireshark for data capture and how to filter this data according to simple rules.